These IF, or intermediate frequency signals, represent the difference frequency between the incoming RF signals and the higher frequency oscillator signal. Here you see a simplified schematic diagram of a dual-gate MOSFET circuit being used as a mixing stage. Notice that the inputs for the RF signal and the oscillator signal both contain tuned circuits. Also notice that the output of the mixer stage contains a tuned circuit as well. The tuned circuit at the output will be tuned to the difference frequency between the two signals being fed into the mixer stage. In both the UHF and VHF mixer stages, the difference frequency is obtained by subtracting the incoming RF frequencies from the local oscillator frequency value. This difference frequency then represents the much lower intermediate frequency values. We will now pause for a short review of the material just discussed. The VHF tuner is designed to receive television channels 2 to 13. Each television channel has a bandwidth of 6 MHz. Television channels 2 through 6 are designated as being low-frequency VHF channels. Television channels 7 through 13 are designated as being high-frequency VHF channels. Each 6 MHz channel bandwidth contains the picture carrier, the color subcarrier, and the sound carrier. The standard VHF tuner consists of 5 sections. These are the Bowline transformer, an antenna filter circuit, an RF amplifier section, an oscillator section, and a mixer section. The Bowline transformer is used as an impedance matching device between the antenna and the input of the RF amplifier section. The antenna filter circuit is designed to block all unwanted frequencies from reaching the input of the RF amplifier section. The RF amplifier section is designed to boost the weak incoming RF signal to a level sufficient to override any internal electrical noise which may be generated from the mixer oscillator sections. The oscillator section is designed to operate at a frequency higher than the incoming RF signal by an amount equal to the intermediate frequency value. The mixer section is designed to heterodyne the incoming RF signals with the oscillator signal being produced by the local oscillator section. The mixer section then outputs the difference signal into the video IF detector stage. The difference signal will always be a lower frequency value than either the incoming RF signal or the local oscillator signal. This concludes review number 2. At this time, you should stop the video and complete section B in your student workbook. Up to this point in the video, you have examined the circuits used in the UHF and VHF tuner assemblies. By now you should have gained an understanding of how each of the various sections contained within the tuner assemblies functions. In this portion of the video, you will examine how the tuner is able to select one channel from the many channel frequencies which are being inputted at the antennas connected to the tuner inputs. Making the tuner stages selective requires that 3 of the sections contained within the tuner assemblies be adjusted simultaneously to the desired frequencies. In the VHF tuner, these 3 sections are the RF amplifier, mixer, and oscillator sections. In the UHF tuner, these 3 sections are the preselector, mixer, and oscillator sections. Channel selection may be accomplished through the use of mechanical means or through the use of solid